The second kind of generic we can create is a generic class. Just as with generic methods, by adding a type parameter after the class name, we define a generic type that can be used inside of the class. To instantiate an object from the generic class, we use the standard notation, but with a type parameter specified after both class names. Note that in contrast to generic methods, a generic class must always be instantiated with a type parameter explicitly specified. Next, let's take a look at how inheritance works with generic classes. A generic class can first of all inherit from a non-generic class, which is also called a concrete class. Second, it can inherit from another generic class that has its type parameter specified, a so-called closed constructed base class. And finally, it can inherit from an open constructed base class, which is a generic class that has its type parameter left unspecified. Note that a generic child class needs to supply the same type parameters that are used by the open constructed base class, even if the child class doesn't need them. This is because only the child class's type parameters can be sent along when the class is instantiated. This also means that a non-generic class can only inherit from a closed constructed base class and not an open one, because a non-generic class cannot specify any type parameters when it's instantiated. The third type of generic we can create is a generic interface. These have the same two purposes as regular interfaces, but they are used for generic classes instead, either to expose members of a generic class that will be used by other classes, or to force a generic class to implement a specific functionality. In this example, that specific functionality is the compare method defined in the generic iCompare interface located in the system collections generic namespace. A delegate can also be defined with type parameters. As an example, we here have a generic delegate that uses its type parameter to specify the referable method's parameter. From this delegate, we can create a delegate object that can refer to any void method that takes a single parameter, regardless of its type. Generic delegates are also useful when defining events. For example, instead of using the typical design pattern where the sender of the event is the object type, we can, by using the type parameter, allow the sender's actual type to be specified, and thereby make the argument strongly typed. In general, using the object type as a universal container should be avoided. The reason why object containers, such as the ArrayList, exists in the .NET class library is because generics were not introduced until .NET Framework 2.0. When compared to using the object type, generics not only ensures type safety at compile time, but they also remove the performance overhead associated with boxing and unboxing value types into an object container.